The universe is expanding. Not gently, not slowly, but with a silent force so vast that every second the space between distant galaxies stretches by thousands of miles. In the darkness between those galaxies there is no sound, only the faint hiss of ancient radiation, only the quiet pull of distant gravity, only the whisper of space-time itself unfolding. And yet something impossible is happening. Space is growing, not into a boundary, not into a container, not into some hidden realm waiting to receive it. It grows by creating the very concept of where as it expands. If there is nothing outside the universe, then what does it mean for the universe to grow? This is the mystery we step into now. The journey begins with a simple image, a balloon inflating in a quiet room. The rubber stretches outward, pushing against the air that surrounds it. It grows into something because something already exists around it. That is, expansion, as our minds understand it. But the cosmos does not follow the rules of our living room. The universe does not have a surrounding atmosphere. It does not drift inside a larger space. It is the space. Every inch of expanding distance between galaxies is created from within, not added from beyond. There is no outside. There is no edge. The boundary of the universe exists only as far as light can travel. And beyond that lies more universe, unseen, unreachable, but undeniably there. This breaks the intuition shaped by our everyday world. Everything we know expands into something. Plants grow into air, ice spreads across water, cities stretch into surrounding land. But cosmic expansion is not growth into emptiness. It is growth of emptiness. The fabric of space-time stretches. Distances increase. Galaxies drift apart without moving at all. To understand how we learned this, picture a beam of ancient starlight crossing a universe that refuses to stay still. That beam begins its journey as blue or red or ultraviolet, a fingerprint from a distant galaxy. But space-time stretches beneath it. Every wave is pulled longer. Every crest drifts farther from the next. By the time this wounded light reaches our telescopes, it carries the scars of the universe's growth. This stretching of light, cosmological redshift, is the smoking gun of expansion. It reveals that the galaxies are not racing outward. The distance between everything is increasing. The universe is drafting its own map as it grows. The scale of this expansion defies imagination. A photon that once burned in ultraviolet brilliance now arrives as a whisper of infrared heat after being stretched nearly 40-fold. That means the universe was 40 times smaller when that light began its journey than it is now. Space didn't just expand, it transformed. And this transformation isn't happening somewhere else. It's happening here, in this room, between your eyes and the device you're reading from. Space attempts to stretch everywhere, all at once. But on small scales, forces hold the world together. Molecular bonds resist expansion. Gravity keeps planets in orbit. Electromagnetism binds atoms into matter. Only across the grand distances between galaxies does expansion break free. In those vast reaches where nothing anchors space, the stretching runs wild. To understand how far this expansion extends, imagine standing at night and looking upward. You think you see the universe, a grand sky full of stars, a horizon without walls. But you are seeing almost none of it. You are trapped in a sphere carved out by time. Light travels at a finite speed. The universe has a finite age. Together they create your cosmic cage. No matter where you look, you see only as far as light has had time to travel, roughly 46 billion light-years in every direction. Beyond that limit lies a cosmos far larger, perhaps infinite, but forever hidden from your eyes. The universe continues, but you cannot follow. This boundary is not physical. It is informational, a wall made of time, not matter. Even the oldest light, the cosmic microwave background, arrives from a moment when the universe was still wrapped in glowing plasma. Before that moment, the cosmos was so dense that photons could not travel freely. A cosmic fog blinded everything. Only when atoms first formed and the fog lifted did light break loose and begin the journey that ends at your eyes. This ancient radiation is the oldest thing you can ever hope to see. It is the true horizon of sight. Beyond it lies darkness, not because nothing exists, but because nothing from there can ever reach you. And yet, the horizon moves. Every second, it grows by 1 light second. Every day, we see billions of new miles come into view. Not because the universe shrinks its secrets, but because time allows more light to arrive. Still, expansion complicates this growth. The regions of space that emitted the ancient light now sit tens of billions of light years farther away than when they released it. We see their past, not their present. The further we look, the deeper into history we fall, until we reach a moment when the universe itself was too young to allow sight, a moment forever locked behind the fog of its earliest fire. All of this leads to a truth more profound than it first appears. The universe does not expand into anything. It expands by creating more of itself. The question, what is it expanding into, dissolves under the weight of its own assumptions. There is no external stage, no surrounding void, no cosmic container. The universe defines space, and when it grows, that definition grows with it. It is expansion without destination, growth without boundary, creation without outside. And now, with the stage set and space-time stretching beneath us, the story deepens. The next step in this journey pulls us toward the most disturbing boundaries of sight, the nature of the cosmic horizon and the prison made of time itself. The journey deeper into expansion begins with a simple truth. The universe is growing everywhere at once, not from a center, not from an edge, but from every point in existence, including the space you occupy now. And to understand this growth, we must return to the earliest signs humanity ever saw of a moving cosmos. It began with faint glimmers from faraway galaxies, tiny smudges of light drifting at the edge of our telescopes. Their glow carried a pattern, a stretch, a shift, a quiet message written across billions of light years. As astronomers measured them, a strange revelation appeared. The more distant the galaxy, the faster it seemed to recede. Not by inches, but by miles. Thousands of miles every second. The sky itself behaved like a rising tide, pulling everything outward. But these galaxies were not fleeing through space. They were being carried by it. Imagine raisins inside rising dough. The raisins remain still, yet the dough expands, and each raisin drifts away from the others. The distance grows, not because of motion, but because the dough itself increases. In the universe, galaxies are those raisins. Space is the dough. And the rise never stops. In this expanding sea, nothing holds a privileged position. If you stood in a distant galaxy and watched the heavens, you'd see the same expansion pattern we see from here. Every point appears like the center, not because it is the center, but because expansion happens everywhere equally. This reveals a profound truth about cosmic motion. Nothing drifts outward from a single place. Everywhere drifts outward from everywhere else. With expansion woven into every corner of the cosmos, the next question emerges. How far does our view reach? We stand inside a spherical bubble of visibility, a horizon carved not by walls but by time. Every photon that reaches us brings an echo from the past. The older the light, the farther it has traveled. Yet the universe has only allowed 8 billion years for light to move. No signal older than that can ever reach us. But expansion complicates this limit. The galaxy that sent us ancient light sat much closer when that journey began. Now, after billions of years of stretching space, it lies far beyond the naive boundary of 8 billion light years. Today, that same galaxy resides roughly 46 billion light-years away. This is the observable universe, not the entire cosmos, but the portion whose light has reached us so far. Beyond this horizon lies more universe, unseen, undetectable, yet mathematically certain, and the regions beyond our reach continue expanding away, carried by space faster than light can cross the growing void. Faster than light recession is not a violation of cosmic limits. Objects cannot move through space faster than light, but space itself can grow without restraint. Expansion has no speed limit. As expansion accelerates, more galaxies slip beyond our cosmic shoreline. Their last photons race toward us but will never arrive. They fade from view, not by dying, but by drifting into a distance light can no longer conquer. A future awaits where only our local cosmic neighborhood remains visible. A few dozen galaxies bound together by gravity endure the pull of growing space, refusing to drift apart. Everything else will vanish into darkness, not destroyed, but separated forever by expanding spacetime. Even now, as we look across billions of years, expansion warps our perception of time itself. Light from remote galaxies arrives with its pulses stretched, slowing the rhythm of the events it carries. Supernovae explode in slow motion. Galaxies shine more gently. Entire cosmic histories unfold at half speed or slower. Expansion stretches time just as surely as it stretches space. Somewhere near the edge of our observable limit, time unfolds 10 times slower than it does here. And yet, from that distant vantage point, our region of the universe would seem the one moving in slow motion. There is no universal pace. The flow of time changes with distance and motion and cosmic evolution. This reveals a startling idea. The universe has no single present moment. Every distant region experiences time differently. The deeper we look into space, the further we peer into history. Eras long vanished locally, but still unfolding in distant corners of the cosmos. Expansion turns the universe into a layered record of its own past. While space stretches, the scale of its earliest moments becomes even more astonishing. Everything visible today, every star, world, and cluster, was once contained in a volume no larger than a beach ball, not inside a beach ball. That volume was the entire universe. No outside, no surrounding emptiness. Only compressed spacetime beginning its long expansion. As this expansion continues, it shapes the destiny of everything. Gravity slows expansion on small scales. Dark energy accelerates it on large scales. The cosmic battle between attraction and repulsion sets the rhythm of the universe's future. And it is a battle for the ages. Gravity tries to gather matter into stars, galaxies, clusters. Dark energy pushes everything apart relentlessly. For billions of years, gravity dominated. Then, roughly 5 billion years ago, something changed. Dark energy took the lead. Expansion sped up. Acceleration became our cosmic future. Now the universe races into a destiny defined by this tension. Will expansion continue forever, stretching matter into silence? Will it tear reality apart in a final violent rip? Or will new physics reshape the journey ahead? In the growing darkness of cosmic time, these questions shape the path forward. The observable universe is only a small island in a sea we cannot reach. Beyond our horizon, creation continues. New galaxies forming, stars igniting, worlds rising. And yet none of it will ever enter our sight. We are travelers inside an expanding bubble of visibility. We watch the past unfold at every distance. We stand on the shore of a cosmic ocean that keeps pulling away. And as the horizon stretches, a deeper truth begins to surface. Expansion is not just a feature of the universe. It is the engine that shapes existence, governs time, and defines what can ever be known. Ahead lies the story of ancient light, the cosmic fog that once hid the newborn universe, and the invisible boundary beyond which no information can return. The oldest light in the universe is still arriving. Not from stars, not from galaxies, but from a time before either existed. A moment when the cosmos was young, hot, and wrapped in a glowing fog so dense that no photon could escape. This light drifts toward us from every direction, bathing the universe in a faint, uniform glow. It is the cosmic microwave background, the afterglow of creation. A message carried across 8 billion years of expanding space. But before this ancient light began its journey, the universe was unrecognizable. It was a sea of charged particles, protons, electrons, and photons trapped together in a violent brightness. Light scattered endlessly, unable to travel more than a few inches before being absorbed or redirected. The cosmos was opaque, as blinding and impenetrable as the surface of a star. Then the universe expanded. An expansion cooled everything. About 380,000 years after the beginning, temperatures dropped low enough for electrons to bind with protons. Neutral atoms formed. The cosmic fog lifted. For the first time in cosmic history, light could travel freely, no longer trapped in the early plasma. Those first liberated photons are the same ones reaching us today. They have crossed a universe that refused to stay the same. Their journey began when the universe was 1 billion times smaller than it is now. Their wavelengths have stretched from brilliant visible light into microwaves, faint, cold remnants of what they once were. This stretching reveals exactly how space grew beneath them. When satellites map this ancient glow, they see something astonishing. The early universe was almost perfectly smooth. Temperature differences across the sky are so faint, only millionths of a degree, that the cosmos appears polished, uniform, calm. But hidden inside those tiny variations is the blueprint for everything that exists now. They reveal where matter gathered more densely in the early universe, where future galaxies would form, where clusters would rise, where voids would expand. Those subtle ripples in temperature show the seeds of structure that inflation once stretched from the quantum scale to the cosmic scale. The galaxies in the sky today are the frozen echoes of microscopic fluctuations. But the cosmic microwave background is more than a map of the past. It is the edge of everything we can possibly observe. No photon older than this light can reach us. Beyond that moment lies a wall of early universe plasma forever blocking our view. It is not a physical wall. It is a boundary of knowledge. A curtain drawn across the youngest part of cosmic history. Even now this horizon expands. Every second, new regions of the early universe come into view as their ancient photons finally arrive, but the galaxies that emitted them have already raced far beyond our reach. Expansion ensures that the observable universe grows, while its sources recede. This creates a paradox of perception. We see deeper into the past each day, yet the present locations of those ancient sources move farther from us faster than light can bridge. Every night, sky becomes a time machine, a window into epochs long gone, a gallery of vanished moments painted across the dark. And as we study this ancient light, another truth presents itself, one that redefines the scale of reality. Our observable universe contains roughly 2 trillion galaxies, but the actual universe may be infinite. If so, then our visible bubble contains effectively 0% of existence. Everything we can observe, measure, detect, or imagine is a tiny pocket in a much larger cosmos. Beyond our horizon, the universe almost certainly continues. More galaxies, more stars, more worlds, perhaps even other regions that mirror our own. If space is truly infinite and uniform on the largest scales, then every possible arrangement of matter must repeat somewhere. Not metaphorically. Mathematically. Different versions of every star, every galaxy, every person, arranged in unimaginably distant repetitions across an endless expanse. Yet for all this immensity, our view remains limited. No telescope now or ever built can break the boundary defined by time. We live inside a cosmic fog bank, seeing only the faint circle illuminated by ancient light, and beyond that fog lies everything we cannot reach. But the limits of visibility tell only part of the story. Expansion does more than hide the universe from us. It reshapes the very fabric of what is possible. Right now, the space between clusters grows so quickly that no force can pull them back together. The universe moves toward isolation, each island of galaxies drifting alone into ever-deepening darkness. And yet, within each island, gravity persists. Stars form. Worlds rise. Life may flicker into existence wherever conditions allow. For a cosmic instant, complexity flourishes. Patterns emerge. Questions are asked. But expansion, silent and patient, continues its work. It stretches ancient light. It deepens the cosmic horizon. It dims the glow of the galaxies. It pulls the fabric of existence toward futures colder and emptier than anything we can now imagine. Still, within this story of growth and separation lies the next revelation, a force woven into the vacuum itself. A hidden engine that drives expansion forward with increasing power. Ahead lies the mystery of dark energy, the discovery that shattered our understanding of cosmic destiny, and the realization that empty space is anything but empty. The universe is not slowing down. It is speeding up. This discovery arrived quietly, hidden inside the faint glow of distant stellar explosions. Astronomers expected to measure a gentle deceleration, a universe gradually slowing under the pull of its own gravity. Instead, they found something impossible. The farther they looked, the faster expansion became. Galaxies weren't just drifting apart. They were accelerating away, as if pushed by an invisible force woven into the vacuum itself. This force is now called dark energy. And it dominates everything. Spread evenly through all of spacetime, it fills every cubic centimeter with a faint but relentless pressure. Unlike matter, which clumps together, or radiation, which thins as space expands, dark energy remains constant. It does not fade with distance. It does not weaken with time. As space grows, dark energy simply appears in the new space, maintaining the same density everywhere. And this constancy changes the fate of the cosmos. It ensures that expansion not only continues, but accelerates. To grasp its power, imagine the universe billions of years from now. The galaxies that once filled the night will fade beyond visibility, carried away faster than light can follow. Their last photons stretch into darkness before ever reaching us. The universe becomes emptier not because things vanish, but because expansion outruns sight itself. This acceleration began around the time our solar system formed. Before that moment, gravity held enough influence to slow the growth of space. After that moment, dark energy took command. The universe switched from deceleration to acceleration. The cosmos turned a corner and began racing toward a future defined by emptiness. Yet dark energy remains a mystery. We cannot see it. We cannot touch it. But we can feel its pull in the shifting of the galaxies, in the stretching of ancient light, in the accelerating growth of the cosmic horizon. One explanation suggests dark energy is vacuum energy, the restless activity of the quantum vacuum. Even in perfect emptiness, virtual particles flicker into existence, borrow energy from nothing, and disappear again. This invisible turbulence fills all of space, and the energy it contains creates a subtle pressure, a pressure strong enough to push galaxies apart. But theory predicts an absurd amount of vacuum energy, enough to rip the universe apart instantly. Yet observations reveal only a tiny fraction of that energy actually influences cosmic expansion. This mismatch of 10 to the power of 120 is the greatest discrepancy in all of physics. Some unknown mechanism must suppress nearly all vacuum energy, allowing only a faint residue to remain. That residue is what we call dark energy. Other possibilities suggest dark energy may be a new field, similar to electromagnetism but far more subtle. Or perhaps gravity itself behaves differently on the largest scales. Our understanding of physics may be incomplete in ways we have yet to imagine. But whatever dark energy is, its presence shapes everything to come. As the universe expands, dark energy becomes more dominant, matter spreads thinner, galaxies drift farther. Gravity weakens across cosmic distances. The balance of forces tips toward acceleration, and the cosmos moves steadily toward a fate ruled by empty space. This future unfolds slowly at first, then relentlessly. In 10 trillion years, the universe becomes a gallery of isolated galaxies. In 100 trillion years, star formation ends. In 1 billion trillion years, even atoms may decay. Dark energy guarantees that isolation deepens, that light grows colder, that matter spreads thinner. That time moves into epochs, without stars, without heat, without life. In some models, this future becomes even more violent. If dark energy strengthens over time, it could trigger a final catastrophe. The Big Rip. In that scenario, acceleration grows so extreme that gravity fails on all scales, galaxies come apart, solar systems disintegrate, planets drift into darkness. Even atoms lose their cohesion as the expansion overwhelms the forces binding their nuclei. But the Big Rip is only one possibility. If dark energy remains constant, the cosmos approaches heat death. A quiet fading into darkness where nothing changes, because nothing remains capable of change. Both destinies emerge from expansion itself. Both reflect the same relentless stretching of space. This stretching reveals something deeper. Expansion doesn't depend on what lies outside the universe. It depends only on what lies within it. The matter, the radiation, the vacuum energy, the geometry of spacetime. The universe expands because its own contents demand it, and the effects reach into the fabric of time. As dark energy accelerates expansion, distant events slow dramatically. Entire galaxies appear frozen, unfolding their histories in slow motion as their light stretches across the growing void. What happens there may take billions of years to reach us, and by the time it arrives, the galaxy may have disappeared beyond the cosmic horizon. Expansion hides the present behind veils of time. In this accelerating universe, even the definition of now becomes local. Simultaneity dissolves across cosmic distances. The far reaches of the universe experience time differently. No two distant observers ever shared the same moment. This reveals a deeper truth. Expansion is not just a change in size. It is a change in the structure of spacetime itself. What began as stretching distances becomes a reshaping of cosmic history. A divergence of timescales. A separation of events. A slow drift toward futures no observer can fully witness. And yet the story grows stranger still. For within this expanding universe, there remains a question more fundamental than dark energy, more mysterious than acceleration, more profound than the destiny of galaxies. Where did this expansion begin? And what force could have unleashed it so violently that the universe itself sprang into being? Ahead lies the story of cosmic inflation, a moment so fast, so powerful, that it created the very stage on which the universe unfolds. Before galaxies formed, before stars ignited, before atoms cooled, the universe experienced the most violent growth spurt in its entire history. It was the fraction of a second known as cosmic inflation, a moment when expansion didn't just accelerate, it erupted. In less than a trillionth of a trillionth of a trillionth of a second, the universe grew from smaller than a proton to something large enough to contain everything we see today. Not by motion, but by the exponential stretching of spacetime itself. Nothing in nature grows this quickly. Not explosions. Not supernovae. Not galaxies colliding. Inflation outpaced them all. The universe didn't simply expand. It doubled in size again and again, so rapidly that light itself couldn't keep up. Distances became so enormous, so quickly, that regions once close enough to communicate were ripped apart forever. The universe broke its own speed limit, not by violating it, but by stretching the stage on which the limit exists. What could unleash such power? According to theory, the universe was filled with a field trapped in a state known as a false vacuum, a high-energy configuration that refused to settle. As long as the field remained stuck, its energy acted like a supercharged form of dark energy, propelling space outward with unimaginable force. Then, almost instantly, it decayed. That decay released energy, reheating the universe and filling it with the particles that would eventually form atoms, stars, and galaxies. Inflation ended, but its after effects shaped everything that followed. It smoothed the early cosmos. It flattened the geometry of space. It stretched microscopic quantum ripples into seeds for future galaxies. The structure of the modern universe, the web of clusters and voids, the distribution of galaxies, the patterns frozen into ancient light, all trace back to quantum fluctuations inflated to cosmic scale. This means everything you see today began as a whisper in the quantum foam. Yet inflation raises a deeper question. If it happened once, why would it stop? Quantum theory suggests it may not have. Inflation could be eternal, continuing in distant regions of space where the false vacuum never fully decayed. New pockets of normal space would appear whenever the field collapsed locally, each pocket becoming its own universe with its own expansion history. Our observable cosmos would be just one bubble in a vast, ever-growing sea of inflation. Each bubble could contain different laws of physics, different particle types, different constants, different possibilities. The multiverse would not be a metaphor. It would be the natural consequence of inflation's unstoppable momentum. In this view, the universe did not begin at one point. It began everywhere, continuously, in countless inflationary eruptions spread across a larger reality we cannot access. But even if our bubble is unique, inflation left signatures behind. Its rapid stretching smoothed out the early cosmos so completely that the cosmic microwave background is uniform to extraordinary precision. Without inflation, distant regions of the universe should not share such similarity. There was not enough time for light to travel between them. And inflation did something else. It flattened space. Any curvature that may have existed in the earliest moments was stretched so widely that, on cosmic scales, the universe appears geometrically flat. Parallel lines stay parallel. Triangles meet the familiar sum of 180 degrees. We live in a cosmos so subtly curved, if at all, that our instruments cannot detect the difference. Inflation also amplified quantum ripples. Tiny fluctuations in the inflaton field created small differences in density. Those differences grew over time into the first clumps of matter. Without them, the universe would be a smooth fog forever. No stars, no galaxies, no planets, no life. You exist because of quantum uncertainty magnified by inflation. Yet the implications deepen. If inflation still occurs elsewhere, new universes may be forming at this very moment. Each isolated by distances too vast for light, or anything, to cross. Their histories play out independently. Their futures unfold by their own rules. Some expand forever. Some collapse. Some never cool enough for atoms to form. Some remain trapped in perpetual inflation, never transitioning into structures like ours. And if these bubbles truly exist, then the concept of the universe expanding into something takes on a new meaning. Expansion isn't growth into a larger space. It is the growth of spacetime itself. Each bubble creates its own region of space, its own time, its own physical reality. Nothing outside the bubble is required. The bubble brings its own outside with it as it grows. But inflation introduced another possibility, one far more unsettling. If the false vacuum can restart expansion, then a new inflationary bubble could form anywhere at any time without warning. It would expand outward at the speed of light. Anything inside it would be torn apart instantly, rewritten by new physics, unable to survive. No alarm. No sign. No possibility of escape. The universe could reset itself in a single flash of rebirth. This is not a prediction of doom. The probability is extraordinarily small. But it is a reminder that the forces shaping our universe are vast beyond comprehension, rooted in quantum realities that lie far beneath the scales we observe. Inflation explains why the universe looks the way it does, why expansion appears uniform, why the cosmic microwave background is smooth, why galaxies formed where they did, why spacetime behaves as it does. But the questions inflation raises are even greater. If our universe is only one bubble among many, then what lies beyond our cosmic horizon may never be accessible. Other universes could sit just beyond reach, separated not by distance, but by the physics that define their existence. And as inflation created spacetime, as dark energy stretches it further, the universe continues evolving toward futures stranger than its beginnings. Ahead lies the turning point. The moment expansion begins to shape not only space and time, but the fate of matter itself. Expansion is not gentle, not patient, not passive. It is a force that rewrites the destiny of everything it touches. As the universe ages, the balance between gravity and expansion shifts. In the early cosmos, gravity held the crown. Matter was dense, close, hot. Expansion slowed as gravity fought to gather the first clouds of gas, the first stars, the first galaxies. Structure emerged from resistance. But as billions of years passed, matter thinned, galaxies spread out, the web of cosmic filaments stretched wider, gravity weakened across the great emptiness. And then, quietly, expansion took command. The turning point arrived around 5 billion years ago. Dark energy began to dominate. And the universe stepped into a new era. An era where expansion no longer slowed but accelerated. From that moment on, the cosmos stopped building and began drifting apart. Galaxies that once belonged to vast clusters now move ever farther from each other. The dark voids between them grow wider. Light takes longer to travel, stretching into deeper and colder wavelengths as it crosses the expanding fabric of spacetime. Acceleration does not simply separate objects. It separates eras. The farther away we look, the younger the universe appears. A galaxy 10 billion light-years distant shows us an age when stars were young and matter-rich. A galaxy 12 billion light-years away reveals an era before our sun existed. Farther still, the universe transforms into something stranger, smaller, hotter, more crowded. Expansion becomes a time machine that erases the present and exposes the past. But as dark energy tightens its grip, the universe drifts toward futures shaped by isolation. The clusters that remain bound by gravity will become cosmic islands. Each island, separated by accelerating expansion, will be unable to communicate with the others. Stars will continue to shine within each island. Planets may form. Life may arise anew. But the universe beyond those local islands will fade into perfect darkness. This isolation deepens as time moves forward. In trillions of years, star formation will stop entirely. Gas becomes too spread out for gravity to gather. The great factories of starlight shut down. The cosmos enters a long age of cooling remnants, white dwarfs, neutron stars, black holes drifting inside an expanding void. Yet even these remnants cannot escape the slow reshaping of spacetime. Expansion stretches every wavelength of radiation those remnants emit. Their faint heat drifts into cold emptiness. Eventually, even the echo of their last warmth dissolves into the expanding fabric of the universe. A quiet future unfolds where matter thins into nothingness. And in this thinning cosmos, another force awakens: quantum decay. Over unimaginable stretches of time, protons may break apart. The atoms that formed stars and planets dissolve into fundamental particles. The matter of the universe fades. If gravity clings to anything in these distant epochs, it clings to black holes, massive and dense, still holding the remains of cosmic history. Yet even black holes cannot resist eternity. They evaporate through Hawking radiation, slowly radiating away their mass, until nothing remains but the quiet hiss of photons disappearing into infinite cold. The universe moves toward heat death, a state so empty and uniform that nothing can happen, because nothing remains capable of change. But this is only one future. There exists a far more dramatic possibility, that the acceleration we observe is only the beginning. If dark energy strengthens over time, expansion could devour everything. The process would begin gently, then grow into a cosmic catastrophe known as the Big Rip. Gravity would fail, then the bonds that hold solar systems together, then the forces that bind planets, then the molecules that make matter solid, then the atomic structure itself. Space would stretch faster than matter can respond. Everything would be torn apart, down to its smallest components. The universe would not end quietly, but violently. A final shattering of spacetime. Nothing survives a universe that outruns its own structure. Not galaxies. Not atoms. Not the fabric that defines distance and time. But even this nightmare is not the final question. The deeper mystery lies in what expansion reveals about reality. Because as space stretches, it does something no ordinary substance can do. It grows without needing a where to grow into. Space does not spread into emptiness. It creates emptiness. Every new cubic light year that appears is not carved out of some external realm. It emerges from the expansion process itself, created by the energy of the vacuum, shaped by the curvature of space-time, and governed by forces that operate far beyond our everyday experience. Dark energy ensures that this creation continues, not by adding new space onto old space, but by stretching the metric that defines distance. It is the fabric of reality, expanding itself. This means the universe's acceleration is not motion outward. It is the increase of separation between points, the growing gap between what once was connected. With each passing epoch, expansion takes a little more from the universe. The light we can see, the structures we can reach, the regions we can meaningfully understand. Yet it also brings clarity. It reveals that existence is not contained within something larger. It is the container. It is the stage. It is the boundary and the boundary maker. The question of what lies outside dissolves, not because an answer cannot be found, but because the question never applied to the universe at all. And as expansion continues, as galaxies fade, as ancient light stretches thin, as space-time pushes its limits, a deeper transformation unfolds. The universe begins to challenge the very idea of space and time. Ahead lies the era when matter dissolves, when energy drains away, when expansion dictates the rhythm of reality itself. And in that distant future, something stranger still may occur. a universe so empty and stretched that even time loses meaning. Right now, space feels solid, stable, predictable. A quiet stage on which galaxies drift, stars burn, planets orbit, and life asks questions about its own origins. But this is an illusion created by scale, by distance, by the temporary calm between two storms. On the largest scales, space is not silent. It is active, restless, a fabric under tension. And the engine driving that tension is vacuum energy, the quantum fuel of cosmic expansion. To understand the universe's relentless growth, we must look not at galaxies or stars, but at the smallest scales imaginable. A realm so tiny that the laws of physics dissolve into uncertainty. This is the domain of the quantum vacuum, and it is anything but empty. Zoom in far enough, past molecules, past atoms, past nuclei, past quarks themselves, to distances a trillion times smaller than a grain of sand. Here, space begins to boil. Virtual particles erupt into existence, annihilate, reappear, disappear, and interact in time spans so brief they are nearly unmeasurable. Space is not a void. It is a storm. At every location in the universe, in every cubic centimeter of seemingly empty space, particles flash in and out of existence, energy rises and falls. Fields ripple with chaotic fluctuations. A sea of quantum activity churns continuously, spilling effects upward into the world we can see. This quantum foam is the foundation of everything, and the source of a profound cosmological problem. Because according to the equations, this seething vacuum should contain enormous energy. So much energy that space ought to expand violently, far faster than we observe. So much energy that the universe should have torn itself apart the moment it formed. Yet it didn't. What we measure in the real universe is tiny. The vacuum energy driving cosmic expansion, dark energy, is faint, subtle, barely detectable on human scales. There is a difference of 10 to the power of 120 between what quantum theory predicts and what the universe reveals. This is not a small discrepancy. This is the largest mismatch between theory and observation in the history of science. A number so absurdly large that if each atom in the observable universe represented one zero, it still would not be enough zeros. This is the vacuum catastrophe, the central mystery behind dark energy, and solving it might unlock the nature of cosmic expansion. Perhaps most of the vacuum energy cancels itself out. Perhaps positive and negative contributions nearly balance, leaving only a faint residue. Perhaps symmetries in physics remove most of the energy naturally. Or perhaps our understanding of quantum fields is incomplete, hiding a deeper layer of reality. Whatever the explanation, the small remainder that survives, the tiny sliver that doesn't cancel, pushes space apart. Not like a force. Not like pressure. More like geometry rewriting itself. The vacuum energy doesn't dilute as space expands. It remains constant. If you double the size of the universe, you double the amount of vacuum energy. More space means more vacuum. More vacuum means more energy. More energy means more expansion. This creates a feedback loop, a cycle baked into the fabric of reality. And expansion accelerates. This vacuum-driven expansion is why distant galaxies drift away faster and faster, why light stretches into longer wavelengths, why the cosmic horizon grows even as galaxies disappear beyond it. You live inside a universe whose fuel is nothingness. But nothingness is not simple. It is structured. It is active. It is full. Quantum fields permeate every point in space. Electromagnetic fields. The Higgs field. The fields governing quarks and gluons. the fields that define every force and particle. Each contributes something. Each whispers energy into the vacuum, and together they shape a universe that grows not into space, but as space. Yet the quantum vacuum gives us more than expansion. It gives us clues about the deepest structure of reality. Some theories propose that spacetime is not continuous but built from tiny discrete units, the atoms of space itself. If so, then expansion would represent the creation of new units, new building blocks of volume appearing moment by moment. Other theories imagine that space is woven from vibrating strings in higher dimensions, that expansion is the stretching of this higher dimensional geometry. Still others suggest that the universe is holographic, that the information defining our reality resides not within space, but on a distant boundary beyond our ability to detect. In these models, expansion is not the stretching of space, but the continual updating of the cosmic information surface. Yet the strangest possibility is this. Maybe the vacuum is not a background. Maybe it is the main character. Everything that exists, galaxies, stars, planets, atoms, life, might be temporary ripples riding on a sea of vacuum energy. If the vacuum disappeared, everything else would vanish with it. And perhaps the vacuum does something we have barely begun to imagine. Perhaps it evolves. If vacuum energy changes with time, the fate of the universe changes with it. A stronger vacuum leads to the Big Rip. A weakening vacuum leads to cosmic slowdown or collapse. A vacuum that transitions into a new state could trigger inflation again, birthing new universes. In this view, expansion is not the universe's journey. It is its heartbeat. A constant pulse of creation, driven by the quantum froth beneath everything. Yet the most unsettling truth remains this. The vacuum that defines our universe might not be the only kind. Other universes, if they exist, might have different vacuum states, different energies, different expansions, different laws. Their version of nothing would not match ours at all. What feels like empty space to us may be unimaginably dense to them. What fuels our expansion may collapse theirs. What seems stable here could be unstable somewhere else. Our vacuum is our universe. Their vacuum is theirs. And between them lies nothing. And everything. The vacuum is the canvas upon which reality paints itself. And expansion is the canvas unfolding. Ahead lies the next transformation. The moment when expansion becomes stronger than galaxies, stronger than atoms, stronger than time itself. Across the vast darkness, galaxies drift like lanterns on an endless tide. But beneath that gentle motion lies a truth far more unsettling. The expansion of the universe is not steady. It accelerates. Every second, the cosmic fabric stretches a little faster than it did the second before. And this acceleration carries profound consequences that reshape everything. From the limits of what we can see, to the shape of the universe's distant future. To understand what this acceleration really means, picture a horizon. Not the one on Earth where the sky meets the sea, but a cosmic horizon that marks the farthest edge of what light can ever reach. This boundary is not fixed. It breathes. It shifts. It expands. Every moment, the boundary of the observable universe grows by 1 light second in radius, because light that began its journey billions of years ago is just now arriving. But the galaxies that emitted that ancient light have long since drifted far beyond the distance their photons traveled. By the time their light reaches us, expansion has carried those galaxies far outside our reach. This creates a cosmic paradox. We constantly receive new light, revealing new regions of space. Yet the sources of that light have already slipped away into a realm we can never touch. We see where the universe was, never where it is. This moving boundary, this shimmering edge of knowable reality, defines our cosmic prison. From Earth, we can observe roughly 2 trillion galaxies. But beyond that 46 billion light-year horizon lies a universe with no clear limit. A universe we know exists, but will never see. Acceleration deepens this divide. The faster expansion grows, the faster galaxies fade from view. Their light stretches into longer and longer wavelengths until it becomes invisible. Their presence dissolves into darkness. Cosmic acceleration is not just a physical process. It is an erasure. Look at the night sky today, and you witness a universe full of structure. Clusters, superclusters, filaments, webs spanning billions of light years. But this richness is temporary. As expansion accelerates, the great cosmic web begins to thin. Connections stretch. Bridges vanish. Galaxies separate beyond the reach of gravity. The universe's architecture unravels, thread by thread. In the far future, all galaxies beyond our local group will drift away, never to be seen again. The sky will dim. Stars of other galaxies will disappear. The universe will no longer be a tapestry, just an island of light surrounded by infinite darkness. Even the cosmic microwave background, the ancient afterglow of creation, will vanish. Expansion will redshift that primordial radiation until its wavelength exceeds the size of the observable universe. No instrument, no civilization, no technology will ever detect it again. From the viewpoint of future intelligence, the evidence for the Big Bang will be gone. The fingerprints of cosmic origin will be erased, and the universe will appear eternal, unchanging, and empty. Acceleration transforms not just space, but time. Events in distant galaxies slow as they recede, not because time slows for them, but because expansion stretches the intervals of their light as it travels to us. A supernova that brightens over weeks in a nearby galaxy might appear to brighten over months at the cosmic horizon. Far enough away, time seems to stop altogether. Acceleration creates a universe where distant moments freeze. A cosmos where the farther you look, the slower reality appears to unfold. Time stretches with space. This temporal distortion shapes our view of cosmic history. It ensures that some stories written in the stars will never reach us. Some events will remain forever hidden behind a wall of accelerating expansion. And one day, even the nearest galaxies will edge closer to that wall. Acceleration will continue. Dark energy will grow. And the universe will approach a state where motion itself becomes meaningless. Gravity weakens. Starlight fades. Distances inflate. The universe becomes quieter, colder, lonelier. Yet within this quiet, something profound remains. Acceleration is not destruction. It is transformation. A shift from a cosmos shaped by matter and light to a cosmos shaped by the vacuum, an era ruled by dark energy. The universe enters its next phase, not with violence, but with a slow and steady widening of everything. A future awaits in which structure dissolves, memory fades, and the cosmos becomes a vast, dark ocean, with only a few small islands of light. But even in that distant emptiness, the universe keeps moving forward. Expansion does not stop. It does not pause. It does not wait for observers to understand it. It continues, writing the next chapters in silence, stretching spacetime toward a horizon that always recedes, just beyond reach. Ahead lies the moment when darkness becomes the dominant landscape, when energy thins, and when the last traces of the early universe slip away into obscurity. In the quiet drift of deep time, the universe reveals its final truth. Expansion is not simply a process that shapes the cosmos. It is the architect of fate. Every galaxy, every star, every atom that exists today is living within a temporary window. A brief era where matter can still gather, light can still shine, and complexity can still form. But the universe is changing, and the forces that once nurtured structure will one day erase it. To understand this future, imagine the cosmos not as it is now, but as it will be, stretched across unimaginable epochs. Start with the first great transformation. Stars will fade. For billions of years, galaxies have been engines of light, forging heavier elements in their cores, flooding the universe with energy. But these engines are finite. One by one, stars burn out. New stars become rarer as gas grows thin. Gravity tries to pull matter together, but expansion keeps drawing it apart. The night skies of distant civilizations will dim long before the universe grows cold. The shapes of galaxies will soften. Their spirals will blur. Clusters will thin into faint smudges in an ever-expanding dark. Eventually, only the longest-lived stars remain. Small, cool red dwarfs glowing dimly across the cosmic ocean. They endure for trillions of years. But even they cannot last forever. The universe enters the degenerate era, a span so vast that human timescales dissolve into irrelevance. White dwarfs, neutron stars, and black holes become the primary residents of space. Dead stars drift through the expanding void like embers from a forgotten fire. But the transformation continues. Over even longer stretches of time, matter itself begins to fail. Protons, the building blocks of every atom, start to decay. Slowly, relentlessly, until nothing familiar remains. Atoms disintegrate into lighter particles. The material world dissolves. Planets vanish grain by grain. The last remnants of chemistry fade. When this happens, the universe becomes a sea of isolated electrons, lonely photons, and the faint radiation of decaying matter. Without atoms, without structure, without complexity, the universe crosses another threshold. Gravity's last strongholds, black holes, begin their long evaporation. Hawking radiation bleeds energy from their horizons, transforming these titans of collapse into fountains of disappearing mass. One by one, they shrink. One by one, they vanish. The supermassive black holes at the centers of galaxies, once trillions of times the mass of the Sun, take longer than any other objects in the cosmos to fade. But they, too, are temporary. When the last black hole evaporates, the universe enters a final, silent age. Energy spreads thin. Motion loses meaning. All processes capable of generating change disappear. Temperature drifts toward uniformity. Entropy reaches its maximum. This is the heat death of the universe, a state where nothing new can ever happen again. No stars, no galaxies, no atoms, no light that can form patterns, no processes that can build complexity. Just an expanding ocean of near-perfect emptiness, and faint radiation fading into infinity. This is not a dramatic ending. It is a quiet one, an ending by exhaustion rather than destruction. But the story of expansion does not finish here. Because even as structure fades, the universe continues to stretch. Distances grow without bound. Time itself elongates. In the farthest reaches of cosmic history, expansion becomes the only remaining motion. the final transformation in a universe that has exhausted every other form of activity. And in that stillness, a different truth begins to emerge. The universe that created stars and galaxies is not the same universe that drifts into heat death. Its identity shifts with time. Its meaning evolves. Its purpose, if it ever had one, changes with every epoch. And yet, something remains. The expansion that carried galaxies apart also carried information across the cosmos, shaping what could be known, what could be observed, what could exist. The silence of the far future is built from the echoes of its ancient past. The faint radiation drifting through the darkness is the last whisper of the Big Bang, still crossing an ever-growing sea. In that whisper lies the memory of everything the universe once was. The first atoms, the first stars, the first galaxies, the rise of complexity, the emergence of observers, all encoded in the fading glow of a cosmos that expanded not into emptiness, but into ever greater possibility. And when the last embers fade, the expansion remains. A universe still growing, even when there is nothing left to grow. This final transformation reminds us of the most important truth of all. The universe is not defined by what it contains. It is defined by the process that shapes it. A process that began with a burst of unimaginable energy and will end with a quiet, infinite drift into darkness. Yet in this quiet, there is no tragedy, only completion. Expansion carried the cosmos from its earliest chaos to its final calm. It gave birth to stars, planets, and life. It created moments of wonder, moments of discovery, moments of recognition. And even in its final silence, the universe holds one last reflection. Existence was possible. Complexity was possible. Consciousness was possible. Because space expanded. And in that expansion, it made room for everything. In the beginning, there was no space to expand into. No outside. No boundary waiting to be crossed. Yet the universe grew, not outward, but forward, creating space with every moment it existed. This video journeys into that impossible truth. It begins with the expansion we see today. Galaxies drifting apart. Light stretched thin. The cosmic fabric widening under the silent influence of dark energy. But that widening is only the surface. Beneath it lies the engine of reality itself. The quantum vacuum. A turbulent sea of fluctuations that fuels the creation of spacetime. A realm where emptiness is not empty, where the universe builds its own foundation moment by moment. The story then dives deeper into the limits of observation, the cosmic horizon, the 46 billion light-year cage that surrounds every observer. A boundary formed not by walls, but by time. Beyond it lies a universe we know exists, but will never touch. A realm where galaxies multiply, structures continue, and space stretches into distances beyond imagination. From there, the journey expands into the universe's hidden shape. Curved space, flat space, closed loops and infinite planes. The illusion of edges resolved by geometries that fold back on themselves. A cosmos with no center, no outside, no direction in which expansion could push. But the story does not end with what can be seen. It reaches into what might exist beyond our perception. Extra dimensions curled into microscopic scales. Hyperspace hidden behind familiar reality. Parallel universes emerging from cosmic inflation. A multiverse expanding in ways our three-dimensional minds struggle to conceive. Each universe with its own laws, its own structure, its own vacuum. The video reveals how cosmic expansion shapes destiny, how galaxies fade into the dark, how the night sky empties, how the universe shifts from a brilliant childhood to a quiet, distant age, how time itself stretches under the weight of expansion, slowing events at the cosmic horizon until they appear frozen. It explores the far futures, the death of stars, the decay of matter, the evaporation of black holes, the long march toward heat death, not as tragedy, but as the natural evolution of a universe guided by the vacuum's faint push. Then it pulls back even further. It examines the burst that began everything. Inflation, a moment when space expanded faster than light could cross it, shaping the smoothness of the cosmos, stretching quantum ripples into the seeds of galaxies, setting the stage for every star that would ever burn. It touches on the mysteries left unsolved. Why vacuum energy is so small, why space appears flat, why we exist in a brief moment where matter, dark energy, and gravity balance, why the universe appears fine-tuned for complexity. And finally, the story arrives at the question that began the journey. If nothing exists outside the universe, what does it expand into? The answer reveals itself gradually, woven through physics, geometry, and philosophy. The universe expands into itself, into the future, into new space-time it creates, into possibility. This preview sets the stage for a journey across the origin of space, the life of the cosmos, and the meaning of expansion itself. A journey into the nature of reality and the mystery that surrounds everything we are. A journey that begins with a single realization. Expansion is not a motion. It is a transformation. And we live inside it, across the vastness of space. Truths emerge that challenge every assumption about reality. The journey through expansion reveals facts that seem impossible, yet define the world we inhabit. One fact stands above all. The universe has no center. Every point in space experiences expansion in the same way. Stand anywhere in the cosmos and watch distant galaxies drift apart, and the pattern appears identical. Expansion is not pushing outward from a single origin. It is unfolding everywhere at once. Another truth reshapes how we imagine distance. The observable universe extends 46 billion light-years in every direction, even though the universe itself is only 8 billion years old. This is possible because space has been stretching during the entire history of light's journey toward us. The ancient photons arriving today began in a universe far smaller, but expansion carried their sources far beyond the limit their light could ever reach. A deeper insight emerges from the cosmic microwave background. This ancient glow is the oldest light the universe allows us to see. It comes not from stars or galaxies, but from the moment the cosmos cooled enough for the first atoms to form. Before this transition, the universe was opaque, a fog of plasma where no light could travel freely. The transparency we see today is a relatively recent phenomenon in cosmic terms. Even stranger is the smoothness of that ancient light. Across the entire sky, its temperature varies only by millionths of a degree. This near perfection reveals that the early universe was extraordinarily uniform, a feature that inflation explains by stretching tiny fluctuations into cosmic structures. Those tiny fluctuations became something remarkable. They seeded every galaxy, every star, every planet, all from quantum ripples amplified by expansion. The universe we see today is built from the faintest imprints of randomness. Another fact reveals the limits of vision. Most of the universe exists beyond what any observer can ever detect. Nearly all galaxies lie permanently outside the cosmic horizon. their light too slow to reach us before expansion carries them away. The observable universe is not the whole universe. It is only the small portion that light has managed to deliver. This leads to a profound realization. The observable universe will shrink over cosmic time. Acceleration ensures that distant galaxies vanish from view, not because they cease to exist, but because their light becomes too stretched, too faint, too delayed. A future night sky will contain only the remnants of our local group, a handful of galaxies isolated in an endless dark. Another extraordinary truth lies in the nature of time. As space expands, it stretches not only wavelengths of light, but the intervals between the moments that light carries. Time dilation becomes cosmic in scale. Events at the horizon appear to unfold in slow motion, their rhythms elongated by expansion. Even the shape of the universe challenges intuition. Space appears flat to the limits of measurement. Yet flatness does not imply infinity. A flat space can loop back on itself like a vast cosmic donut, a shape so large that light has not had time to complete a single circuit. The universe could be finite and unbounded, its edges closed, its boundaries non-existent. A further insight emerges from the vacuum. Empty space contains energy, a faint push that fills every cubic centimeter of the cosmos. This energy shapes the fate of everything. It accelerates expansion. It defines the universe's long-term evolution. It dominates the cosmic budget more completely than matter or radiation. The vacuum obeys no simple expectations. It does not dilute as the universe grows. New space forms with new vacuum energy, maintaining a constant density while the universe increases in volume. This behavior ensures that dark energy will become even more influential over time. A remarkable fact follows from this. Distant galaxies can recede faster than the speed of light, not because their motion breaks cosmic speed limits, but because space itself stretches between us and them. This superluminal recession is a natural consequence of expansion, not a violation of relativity. Another insight lies at the origin of structure. The universe emerged from early conditions that were almost perfectly smooth, yet expansion magnified microscopic variations. Those variations created the cosmic web. Filaments spanning millions of light years, clusters bound by gravity, voids stretching across space, all from fluctuations smaller than atoms. The future offers its own set of astonishing facts. Stars will fade. Galaxies will thin. Protons may decay. Black holes will evaporate across unimaginable lengths of time. Heat death becomes the natural conclusion of a universe ruled by accelerating expansion. Yet even this quiet ending contains a strange promise. Expansion continues. Space keeps growing. The universe enlarges into its own future, carrying with it the echoes of its origins. Some models reveal an even more unsettling truth. Expansion might not be unique to our universe. Other universes may expand in parallel, each with its own vacuum energy, its own laws, its own horizon. The multiverse becomes an extension of expansion, a vast landscape where reality blossoms repeatedly across dimensions we cannot access. All of these facts, each more surprising than the last, point toward one underlying theme. The universe does not expand into anything. It expands because space itself is dynamic, alive with energy, woven from fields, shaped by geometry, and capable of creating its own volume. Expansion is not a motion outward. It is the continuous unfolding of reality. In the stillness between galaxies, a truth emerges. The universe is not growing into a void, not pushing against an outside, not carving its way through some larger unseen landscape. It is expanding by becoming more of itself. Every moment, space stretches. Every moment, reality deepens. Every moment, the cosmos unfolds into futures it creates as it goes. The journey through this story reveals the most profound transformation imaginable. A universe that began as hot, dense, luminous plasma now drifts through an age of stars, an age of structure, an age of questions. And with each passing second, expansion continues its silent work, shifting galaxies apart, softening the web of matter, drawing new boundaries across the limits of the observable world. Beyond those boundaries lies a universe that will never reach us, a realm carried away by acceleration faster than any signal can cross. The distance grows. The horizon pulls back. The visible cosmos becomes a shrinking island of memory, surrounded by an ocean of unreachable space. Yet even as galaxies vanish into darkness, the meaning of expansion grows clearer. It is the architect of the cosmic past and the author of the cosmic future. It sets the stage for stars to ignite, for planets to form, for life to rise, for consciousness to wonder. It shapes the structure of time itself, stretching moments across billions of years, carrying light through a universe that refuses to stand still. And when the ages ahead arrive, when galaxies soften into faint smudges, when stars fade, when matter dissolves, when black holes evaporate, expansion will continue. Not as a force, but as a property of existence, a quiet widening that outlives every structure the universe has ever known. In the final silence, when the last photon drifts across an ocean of near-perfect emptiness, the universe remains in motion, not toward a destination, but toward possibility itself. It expands because expansion is the expression of spacetime. It grows because growth is built into the fabric of reality. It persists because the vacuum itself carries the seed of creation. Through all of this, a deeper reflection rises. The universe does not expand into anything external. It expands into its own unfolding potential, into the space it continuously produces, into futures that did not exist moments before, into a canvas that paints itself with every passing second. And within that canvas, life appears, brief, fragile, luminous, born from stardust, guided by physics, driven by curiosity. For a fleeting moment in cosmic time, conscious beings open their eyes and witness the expansion from within. They look outward into the darkness and see a universe growing without edge or center. They look inward and discover they are part of that same unfolding. The story of expansion is not just the story of galaxies and horizons. It is the story of perception, of wonder, of a universe vast enough to create observers, and subtle enough to let them ask what it all means. And in the end, the answer is not a boundary or a destination. It is a realization. The universe expands into mystery, into questions not yet asked, into discoveries not yet made, into the endless potential for understanding. It expands into the possibility of us. If this story moved you, don't forget to like, share, and subscribe to your channel name, where we explore the universe through the eyes of those brave enough to venture into the unknown. The cosmos is vast, but every story matters. See you among the stars. Across the cosmic timeline, each era reveals a different face of the universe. The early fire, the rise of structure, the long drift toward emptiness. Each stage reshapes not only matter and energy, but our understanding of what it means to exist within an expanding cosmos. This part of the journey turns inward, not to individuals, not to stories of civilizations, but to the meaning carried within the expansion itself. Because beneath the formulas, beneath the distances, beneath the cosmic horizons, lies a quiet truth about the relationship between scale and significance. The universe grows, yet its growth does not diminish what already exists. Expansion does not erase the moments that came before. It stretches them across larger canvases, carrying their echoes through widening space. Every ancient photon traveling from the dawn of time is a message stretched thin by expansion, a moving archive of the universe's earliest memories. It tells us where the cosmos came from. It tells us what it once was. It carries within it the imprint of temperatures, densities, and fluctuations that shaped everything that followed. Each ripple in the cosmic microwave background is a fossil of expansion, a signature preserved across billions of years. A reminder that the universe once glowed brighter than 1,000 suns and cooled through its own widening breath. Even the galaxies drifting apart today are part of this vast memory. Their receding light reveals the rate of expansion. Their redshifts sketch the shape of spacetime. Their fading silhouettes record the universe's progression, from crowded brilliance to spacious calm. And as expansion pushes them farther away, it also places them within a kind of cosmic archive, a record of existence held at the edge of visibility, their light forever reaching us, even as their present forms vanish beyond the horizon. The universe is full of such layered histories, moments separated by unimaginable distances, yet connected by the path of light itself. In this widening cosmos, time becomes a dimension of perspective. Look close, and you see the universe as it is. Look far, and you see it as it was. Look farther still, and you step into ages older than stars, older than galaxies, older than the elements in your bones. This layered vision makes expansion not merely a physical phenomenon, but a revelation machine. Every increase in distance sharpens our understanding of cosmic origins. Every faint photon carries ancient truth. Every horizon reveals a limit, and with it, a hint of what might lie beyond. Expansion gives the universe depth, not just size. It creates the separation necessary for evolution, the cooling necessary for complexity, the stability necessary for life to form. Without expansion, the cosmos would have remained a dense fireball, too hot, too violent, too compressed for stars or planets or observers. Expansion is the quiet architect behind the transformation, from chaos to structure to awareness. And the awareness that emerges does something profound. It reflects. For the first time in cosmic history, matter becomes capable of contemplating the process that shaped it. Atoms forged in ancient stars organize themselves into beings that look upward and recognize their own origins. In this recognition, a new layer of meaning appears. The universe is not just expanding. It is expanding into understanding. Each discovery reveals not only the behavior of distant galaxies, but the nature of existence itself. It shows that space is not a stage, but a participant, a living geometry capable of change. It shows that time is not a river, but a dimension woven into the same fabric as space. It shows that emptiness is not empty, but alive with energy subtle enough to shape the entire future. And when these insights combine, they reveal something breathtaking. Expansion is the universe's expression of possibility. It is the widening that allows new forms to emerge. It is the stretching that gives room for diversity, for change, for evolution. for thought. In a static universe, nothing new could arise. No new stars, no new structures, no new complexity. The cosmos would be trapped in its earliest state, unable to differentiate itself. But with expansion, the universe becomes a landscape of unfolding potential. Every cubic light-year created is a space where atoms may gather, where stars may ignite, where planets may form, where life may appear. Every moment of growth is a moment where new realities can begin. Even the distant future, quiet, dark, sparse, is part of this larger story. Not an ending, but a continuation of a universe that always moves forward. As heat death approaches, as galaxies fade, as matter loses its structure, expansion persists. It carries the echo of everything that once existed, and the possibility of everything that might still emerge in ways we do not yet understand. Perhaps new physics will awaken in the far future. Perhaps the vacuum will shift. Perhaps expansion will trigger new forms of structure, beyond anything familiar. Or perhaps it will continue its quiet widening until time itself dissolves into the distance. Either way, the meaning remains. This universe, vast and ancient, is not static. It is not bounded. It is not confined by an outside or a destination. It grows because that is what spacetime does. It expands because expansion is woven into the nature of existence. And within that expansion, life, brief as it is, finds a moment to look outward and realize that it is part of something far larger than any horizon it can see. In the vast sweep of cosmic evolution, the universe undergoes transitions so profound that each age feels like a different reality. But beneath the changing structures, beneath the fading stars, the drifting galaxies, the deepening dark, lies a thread that connects every moment across time. Expansion. It is the silent pulse of the cosmos, a widening rhythm that began in a flash too brief to comprehend, and continues now with a patience measured in billions of years. This part of the journey turns toward the nature of that rhythm, toward the hidden geometry that shapes it, and toward the deeper question that has followed us since the beginning. How does something with no outside continue to grow? To answer that, imagine tracing a single path of space backward through time. Follow it through the present era where galaxies drift apart, through the age when matter was dense and young, through the era of recombination when the universe glowed like a soft, uniform ember, back through the first fractions of a second when the cosmos was hot, bright, and violent. Then keep going. Back to inflation. Here, space behaves not as a calm fabric, but as a storm of exponential creation. Distances stretch faster than any signal can move. Tiny patches of space-time inflate into vast regions, larger than the observable universe today. And from that eruption of expansion comes the seed of everything: the structure, the stars, the chemistry, the observers. But inflation also left a deeper imprint. It demonstrated that space-time is not static. It can swell. It can reshape itself. It can generate volume without reference to an outside. Inflation did not expand into emptiness. It expanded as space-time. It expanded the definition of location. It expanded the meaning of somewhere. This insight reaches through every epoch that follows. When galaxies drift apart, they do not move through space. Space widens between them. When the cosmic horizon expands, it does not reveal pre-existing territory. New observable regions appear because new space-time forms. And when distant galaxies slip beyond sight, They are not crossing a boundary. The metric of distance is stretching faster than light can bridge. Space is not a container. Space is a dynamic field. Its expansion is not an intrusion into something external. It is a transformation of what already exists. This transformation shapes the cosmic architecture. The universe appears flat, a geometry where parallel lines never meet, where triangles behave as expected, where spacetime unfolds like an infinite plane. But this flatness may be a local illusion created by inflation's smoothing effect. The universe could still curve subtly, so subtly that even the most precise instruments cannot detect the bend. It might be infinite. Or it might wrap around itself in a shape so vast that no beam of light has ever completed a journey around its full circumference. A universe without boundaries does not need edges. It needs only curvature, whether stretched across infinity or looping through higher dimensions. The universe expands not outward, but inward, into its own geometry. Some theories imagine the universe as a hypersurface inside a higher dimensional reality. In that view, expansion is the stretching of a four-dimensional shape embedded in a realm we cannot perceive. Just as a two-dimensional being could never step outside a balloon's surface, we cannot access the dimension into which our universe might curve. But the expansion would still not be movement through that dimension. It would be the shape itself changing. Other theories propose the holographic view, that our universe is encoded on a distant surface, a boundary that stores the information describing everything we see. In such a model, expansion is not the stretching of space, but the unfolding of information, the gradual revelation of new degrees of freedom as time advances. Even more radical ideas imagine that space emerges from entanglement, that connections between quantum states generate distance itself. In this view, expansion happens when those connections reorganize at cosmic scales, reshaping the structure that defines near and far. Across all these frameworks, one idea remains constant. The universe does not expand into anything. It expands because the rules that govern spacetime require it. Expansion is the natural evolution of the geometry we inhabit. Its growth is a reflection of energy, of curvature, of vacuum dynamics, of the quantum fields humming beneath reality. This widening changes the meaning of presence. It ensures that distant regions never share the same moment. It ensures that horizons shift with time. It ensures that observers live inside pockets of visibility that grow and shrink with cosmic evolution. It ensures that the universe has layers, layers of past, layers of potential, layers separated by the speed of light and by the unyielding march of expansion. And yet, even as the cosmos becomes more fragmented, its story becomes clearer. The universe began small not because it needed space outside itself, but because space had not yet been created. It expands now not because it seeks room to grow, but because the vacuum energy embedded within spacetime drives its evolution. It will continue to grow long after stars fade and matter dissolves, not into emptiness, but into ever-widening definitions of space and time. Every horizon, every redshift, every drifting galaxy is part of this quiet transformation. Expansion is not a path. It is a process, not an outward motion, but an internal unfolding. And through this unfolding, the universe writes its own future. A future where galaxies soften into darkness. A future where light loses its structure. A future where spacetime stretches toward silence. A future shaped not by what lies outside, but by the forces within. In that future, the universe continues its journey, not reaching outward, but deepening into the possibilities it creates every moment. As the universe stretches into deeper ages, a shift occurs, not only in matter, not only in energy, but in perspective. Expansion becomes more than a physical process. It becomes a lens through which the entire story of existence can be understood. Every moment of cosmic history, from the earliest flash of inflation to the quiet drift of distant futures, is shaped by this single principle. Space is not fixed. It evolves, and through that evolution, the universe transforms again and again. The familiar age, the one filled with stars, galaxies, and light, is only a brief chapter in a much larger chronicle. For billions of years, expansion allowed matter to gather. It cooled the early fireball so atoms could form. It stretched the universe to the right density for stars to ignite. It set the stage for complex structures to build themselves from the simplest ingredients. Without expansion, the cosmos would have remained locked in uniform brilliance, forever too hot to allow form. With it, the universe became a cradle for complexity. But expansion does not pause to protect what it creates. As the universe matures, the same widening that once nurtured structure begins to disperse it. Galaxies drift apart. The cosmic web thins. Light fades across the widening void. The universe becomes more isolated with each passing epoch. And through that isolation, a new understanding emerges. Growth and loss are woven together. The age of galaxies gives way to the age of remnants, where quiet stars dominate the night. The age of remnants gives way to the age of collapse, where black holes take the final gravitational throne. And beyond even that, the long shadow of heat death stretches across the cosmic timeline, an era where expansion has pushed everything so far apart that motion itself becomes scarce. Yet even in that distant future, the story is not one of emptiness alone. Expansion continues to carry information from the past. Ancient photons, stretched nearly beyond recognition, drift through the darkness with messages from the earliest moments. The last structures to ever form cast their final radiation into a cosmos that has grown too wide to reflect it. In this way, the universe becomes an archive of its own evolution, a record etched into the thinning light and the fading temperature of space itself. Each epoch adds another layer to the archive. The primordial fire, the cooling of the first atoms, the rise of stars, the dance of galaxies, the dominance of dark energy, the slow decay of matter, the evaporation of the last black hole, all written into the universe's expanding canvas. And even when the canvas grows too large for these records to retain meaning, the archive remains in the structure of spacetime, in the very geometry shaped by everything that has ever occurred. Expansion is also a map of possibility. The universe once existed in a dense state where variation was minimal, where chaos dominated every corner, and where the future was uniform and simple. But expansion created room for differentiation. It allowed matter to separate, temperatures to settle, forces to shape structure. It gave the universe the freedom to grow diverse. Galaxies took form sculpted by gravity and chance. Stars evolved according to their mass and surroundings. Planets formed in endless combinations, each unique in its composition and conditions. And somewhere in this vast diversity, observers emerged, brief sparks of awareness, capable of recognizing the expansion that created them. This recognition is part of the cosmic story. When consciousness appears, it becomes the first phenomenon in the universe that can reflect upon the universe itself. It becomes the first vantage point from which expansion can be interpreted, not merely as geometry, but as meaning. Awareness gives expansion context. It allows the widening of space to become more than numbers, more than graphs, more than distant galaxies receding. It becomes a narrative woven into the experience of existence, and that narrative transforms again as time passes. In a universe dominated by dark energy, every observer inhabits a shrinking island of visibility. Horizons tighten. Connections fade. The wider universe slips into silence. And within that silence, observers face a profound realization. The cosmos they can see is not the cosmos that exists. Most of the universe lies forever beyond reach, hidden behind walls of accelerating expansion. These unseen regions continue to evolve, continue to grow, continue to drift into futures parallel to ours, but never intersecting. The universe becomes a collection of isolated realms, each one shaped by expansion, each one unable to witness the others. This separation deepens the mystery. It reveals that the cosmos is far larger than perception allows, far richer than visibility permits, and far more complex than any single era can express. The destiny of the universe, whether heat death, big rip, or renewal, remains tied to the same force that shaped its birth. Expansion is the thread that connects every possibility. Even the idea that new universes may sprout from the quantum vacuum is tied to expansion. Inflation may never have ended everywhere. Cosmic growth may be the mechanism through which reality multiplies. Each new region expanding from its own vacuum state may experience its own laws, its own geometry, its own destiny. In this larger view, our universe is not a singular event, but a chapter in a broader tapestry of expanding realities. And through all these scales, from quantum fields to cosmic webs to multiversal expanses, one truth remains constant. Expansion is not motion through space. It is the creation of space. It is the evolution of the metric that defines distance and time. It is the quiet engine that has guided reality from its earliest instant to its farthest future. The universe does not grow into anything. It grows into itself, a continual unfolding of possibility, a widening of the stage upon which all existence takes place, a never-ending transformation written into the fabric of reality. In the end, the question that began our journey, what is the universe expanding into, unravels into something far deeper than curiosity. It becomes a mirror, a reflection, a reminder that the very stage upon which reality plays is not embedded in some larger arena. It is the arena. It defines the rules, the boundaries, and the meaning of beyond. The expansion of the universe is not the growth of a bubble into emptiness. It is the growth of existence into possibility, a widening of the framework that allows anything at all to occur. Every moment, space increases. Every moment, time stretches. Every moment, the cosmos becomes more of what it is. The universe expands not because it needs room, but because expansion is its nature. From the first fraction of a second, when inflation tore reality open with unimaginable speed, to the gentle acceleration driven by dark energy today, the cosmos has been propelled by a quiet engine, hidden in the vacuum itself. That engine is not a push from outside. It is a pull from within. Expansion is the self-expression of spacetime. And through that expression, everything we know has come into being. Galaxies formed because expansion created room for gravity to sculpt them. Stars ignited because expansion thinned the primordial plasma. Planets assembled because expansion shaped the cosmic web. Life emerged because expansion cooled the universe to the right temperatures, at the right scale, for complexity to bloom. We exist because the universe expands. And even as it pulls galaxies beyond our reach, even as it stretches the cosmic horizon into deeper distances, even as it prepares a far future where silence replaces starlight, expansion remains the foundation of cosmic meaning. For in the widening of space, the universe grants itself the freedom to evolve. It births new eras, new structures, new possibilities. It reshapes time, carving history into vast epochs that no single observer could ever witness in full. It teaches that change, not permanence, is the true signature of reality. The universe expands into landscapes no eye will ever see, regions carried away faster than light can chase them. Yet their existence enriches the meaning of the cosmos we inhabit. They remind us that our view is partial, our horizon temporary, our place in the universe both infinitesimal and extraordinary. Because for a brief moment in cosmic time, the universe created structures capable of looking back at it. Awareness arose. Perspective emerged. A species on a small world orbiting an ordinary star gained the ability to ask questions about the whole of existence, to trace the arc of the universe from its first instant to its farthest end. We are the universe examining itself. We are the consciousness expansion allowed. We are the temporary observers of a permanent mystery. And that mystery deepens with every insight. The universe expands into nothing external, because nothing external exists. The universe expands into itself, because existence is the only container of existence. The universe expands into a future not yet written, because expansion creates the canvas upon which reality unfolds. In this sense, the destination of cosmic expansion is not a place. It is a state, a condition of being, a continual emergence. Expansion is the universe dreaming forward, across trillions of years, long after every star has faded, and every galaxy has dissolved into isolated atoms, long after black holes evaporate, and the last particles drift across the widening void. The universe will continue expanding, softly, silently, endlessly. That future may be dark, but it is not empty of meaning, because the meaning of the cosmos does not depend on the structures it once held. It arises from the very fact of its unfolding. The universe is a story told by expansion, a story of beginnings and transformations, of fire and structure, of silence and thought, a story of matter arranging itself into forms capable of marveling at the process that made them. In asking what the universe expands into, we are really asking what reality is, and where it begins. The answer is simple and profound. It begins here, in the space that expands, in the time that deepens, in the awareness that wonders. No outside, no boundary, no container, just the universe, writing itself into existence with every passing second. And as long as expansion continues, as long as space-time breathes, the story will never truly end. This is not a cosmos running out of space. It is a cosmos creating it, not a universe fleeing into nothingness. A universe flowering into itself, not an expansion into emptiness. An expansion into possibility, and that possibility includes us. Brief sparks, illuminating the darkness, bearing witness to the magnificent, impossible truth that the universe expands, not into anything, but into everything it is still becoming.